In this video, we're going to see how the other trig functions apart from sine and cosine, so secant, cosecant, tangent, cotangent, how those functions operate. So to start, we'll do some basic examples. So these functions operate in much a similar way as sine and cosine. The input for all of the functions is an angle. And what we want to do is we want to find the coordinate from the unit circle that corresponds to the given function. So the first one is secant of 5 pi over 3. So you want to locate 5 pi over 3 on the unit circle. Secant is the reciprocal of cosine. So cosine, a couple ways you can go about this. Cosine 5 pi over 3. We could figure out what that is, and that is 1/2. So the reciprocal of that is going to be 2 over 1, or just 2. So that would be the answer there. I think I said there's a couple ways we can do that. That's the way you want to do that. The next one is cosecant. Cosecant is the inverse function for sine. So we could find the sine of negative 45 degrees first, and then take the reciprocal to get cosecant. So sine of negative 45, well, 45 is here. Negative 45, we just go in the opposite direction around the unit circle. So we're going to end up right here. So that is 315 degrees is equal to negative 45 degrees. We say that these angles are coterminal because they're in the exact same position. So sine of negative 45 degrees, well, sine is the y value, or the y coordinate, so negative root 2 over 2. So cosecant is just the reciprocal of that. So we'd say negative 2 divided by square root of 2. Oftentimes we will rationalize this denominator. So multiply the top and bottom by square root of 2. So negative 2 root 2 divided by square root of 2 times square root of 2 is just 2. And then the 2's cancel. So all that to say, negative square root 2 is the answer there. I do want to say for this one, a common mistake that students will make is they'll say, oh, well, cosecant of negative 45 degrees, well, 45 degrees is down, negative 45 degrees is down here. That means that is equal to 7 pi over 4. Well, that's not correct because 7 pi over 4 is just the angle getting measured in radians. So only the angles only go in the input value of the trig function. So cosecant of negative 45, that's the exact same thing as saying cosecant of 7 pi over 4. It's asking the exact same thing. So we wouldn't want to say that cosecant of an angle is equal to another angle. All right, moving on. Tangent of 120 degrees. So 120 is over here in quadrant 2. Tangent of 120. So tangent is equal to the y coordinate over the x coordinate. So the y coordinate is root 3 over 2. The x coordinate is negative 1/2. The 2's can cancel. We end up with negative square root of 3. All right, and then lastly, cotangent of pi. Pi is over here. Cotangent is the reciprocal of tangent. So tangent was x over y, so cotangent is, tangent was y over x, so cotangent is x over y. The x coordinate is 0. The y coordinate, nope, I'm backwards. The x coordinate is negative 1. The y coordinate is 0. When we have an expression where we are dividing by 0, we say that this is undefined. Okay, so there's a few places on the unit circle where we'll get a value that's undefined. So as I've said in previous videos when we're talking about the unit circle, these are the basic types of questions that you'll get asked, and you need to be able to answer these types of questions without being able to view the unit circle. So if you want some strategies on how to memorize the unit circle, there's a lot out there on YouTube. I also talk a little bit about this in that unit circle video. All right, next example. The point negative root 3 over 2 comma 1/2 is on the unit circle. Find sine of t, cosine of t, tangent of t, etc. So find all the trig function values for this angle t. All that this is saying is what are the trig function values? Well, we really just base it off of these coordinates here. So sine corresponds to the y-coordinate, cosine corresponds to the x-coordinate, tangent is y over x, secant is the reciprocal of cosine, so 1 over x, cosecant is the reciprocal of sine, so 1 over y, cotangent is the reciprocal of tangent, so x over y. All right, so we can get through this one pretty quickly. Sine of t is just the y-coordinate, so 1/2. Cosine of t is the x-coordinate, so negative root 3 over 2. Tangent of angle t is y over x, so 1/2 divided by negative root 3 over 2. The 2's can cancel. We get negative 1 over square root 3. That is an okay answer. Also, to rationalize, multiply the top and bottom by square root of 3, so negative root 3 over 3. And then for the reciprocal functions, I'll do these in order. So cosecant of t is just the reciprocal of sine, so it's 2 over 1, which is 2. Secant of t is the reciprocal of cosine, so negative 2 over square root 3. And if you rationalize, negative 2 root 3 over 3. And then cotangent of t is the reciprocal of tangent of t. Well, I'm going to take this version of tangent, because by taking the reciprocal, I get a radical. I don't have a radical in the denominator. So these are all of the values that we would want. So this one is similar to the last one. We have a coordinate and an angle t. In this instance, as with the last one, t is one of the values that we know from the unit circle. So when we have positive root 2 over 2 and negative root 2 over 2, that corresponds to this right down here. So that angle is 7 pi over t. If we're in radians, or I'm sorry, 7 pi over 4, or 315 degrees. So if I was to say, what is sine of t, that's the same thing as saying, what is sine of 7 pi over 4? Okay? And sine of 7 pi over 4 is just the y-coordinate, so that is equal to negative root 2 over 2. I'm going to keep using the actual angle here, because this is probably a more common way you'll see this type of question. Cosine of 7 pi over 4 is just the x-coordinate. Tangent of 7 pi over 4 is, remember, that's y over x. So the y-coordinate is negative root 2 over 2 divided by root 2 over 2, which is just equal to negative 1. And then cosecant of 7 pi over 4, this is the reciprocal of sine. So this is going to be negative 2 over square root of 2. To rationalize, we get negative 2 root 2 over 2. 2's cancel, we just get negative square root of 2. Secant of 7 pi over 4 is going to be root 2 over 2. It essentially comes out to the same thing as what we had for cosecant. So when I rationalize, I'm just going to end up getting square root of 2. And then cotangent of 7 pi over 4. This is just the reciprocal of tangent. The reciprocal of negative 1 is just 1 over negative 1, which is also negative 1. All right, this one says find sine of t, cosine of t, etc. when t is equal to pi over 6. Remember, t is an angle here because angles go into the trig functions. So one way you can think about this is, if you don't quite have the unit circle memorized yet, we can think about, well, where is pi over 6? Pi over 6 is right here. It's in quadrant 1. And the coordinates for pi over 6 are root 3 over 2, comma, 1/2. And once we have that, it's pretty straightforward to figure out the rest of this information. So my suggestion would be, why don't you pause the video and see if you can figure all of these out. And these are going to be similar to the previous couple examples that we just did. Yeah, so go ahead and pause and see what you're able to come up with. All right, so here are the values for each of the trig functions. So check your work and see what how you did. All right, this one says, use reference angles to find all 6 trig functions for -5 pi over 6. So because it says to use reference angles, let's first figure out what the reference angle is for 5 pi over 6. Well, recall, reference angles are the angles that get us back to the x-axis. So this angle is negative, so -5 pi over 6, so we're going to be going clockwise here. End up something like this. So -5 pi over 6. So the reference angle is going to be this guy right here. Okay? And the shortcut for a reference angle, anytime we have an angle that's in radians, is just to look at the pi and then what the denominator is. So the reference angle is pi over 6. Reference angles are always positive. So the reason we care about the reference angle is because if I look at 5 pi over 6 in the first quadrant, pi over 6 in the first quadrant, the coordinates for pi over 6 are √3 over 2 and 1/2. So we can use these coordinates to figure out the trig function values. The only other piece to remember is our original angle, -5 pi over 6, is in quadrant 3. When we're in quadrant 3, the x-coordinate is negative, the y-coordinate is negative. So really, we're going to use these coordinate values, but just giving them both a negative sign because we're in quadrant 3. All right, so let's go to it. So sine of -5 pi over 6. So think, sine at pi over 6 is just the y-coordinate up here. It's 1/2. But because this is in quadrant 3, we're going to say -1/2. Similarly, cosine -5 pi over 6. Well, the reference angle is pi over 6, which would be √3 over 2. However, we're in quadrant 3. Cosine is negative in quadrant 3, so -√3 over 2. And that's how you'd go about this. So tangent of -5 pi over 6. Well, now I already have the y value and the x value, so I can just divide these together. 2's are going to cancel. Actually, the negatives will also cancel. So this is going to be 1 over square root 3 or √3 over 3. And then let's look at the reciprocal functions. So cosecant -5 pi over 6. This is just the reciprocal of sine, so -2 over 1 or -2. Secant of -5 pi over 6 is the reciprocal of cosine, so -2 over square root 3. If we rationalize, we get -2 square root 3 over 3. And then lastly, cotangent of -5 pi over 6. This is the reciprocal of tangent. I'm going to use this version of tangent, √3 over 1. So that gets us the solution there. So this is a way that we can use reference angles in order to find trig function values. All right, this example is pretty similar to the last one. In this case, the angle we're talking about is 7 pi over 4. So let's find the reference angle. 7 pi over 4 is down here. It would be this angle. So the reference angle is going to be this angle right here, which is pi over 4. Okay, so pi over 4 in quadrant 1. The coordinates there are √2 over 2, comma √2 over 2. And then using reference angles, we need to remember, well, 7 pi over 4 is in quadrant number 4. And the x-coordinate is positive in quadrant 4. The y-coordinate is negative in quadrant 4. So why don't you pause the video and see if you can find the 6 trig function values of 7 pi over 4 now that you've gotten a little bit of a head start. All right, so here are the 6 values. So take special care to make sure that the signs are correct on each of these. And I made a small mistake here. Secant is positive because it's the reciprocal of cosine. Cosine is positive, so its reciprocal is also positive. So one thing I know that when I'm checking these is that 2 of the values will have the same, will be positive, and the other 4 values will be negative. So I knew that secant was negative and it should have been positive.